Alright, so here we go. 7.3, continuing on. Elimination. So before, when we looked at elimination, we only had two systems, two variables. Now we have three systems, three variables. So the process is still the same. Look for the easiest one to cancel out. So if we look at our blue equation and our black equation, the x looks like it can be canceled out. So let's go ahead and do that. If we cancel out our x and add the others together, we'll end up with y plus 4z equals 9 minus 2 is 7. So there's one equation. Now we have to use the equation we haven't used yet. So let's go ahead and grab that purple one. And we're going to use elimination to have that cancel with another one. So let's go ahead and use 1 and 3 again. So I'm going to multiply my first equation by -2. So again, -2x, a positive 4y, and -6z, and -18. And then I'm going to take my purple equation and I'm going to go ahead and add them together. So like I was saying, the process is still the same. These cancel. You get 9y. Oh, looks like I made a sign error. This should be negative. Throw that away. Alright, so we're going to get a -y, -z, and -1. So now you have two equations. We have this equation and this equation. Two equations, two variables. If you look at both of those equations, you can see you've got a y and a -y. So if we add these together, they're going to cancel out really nicely. So let's go ahead and do that. I'm just going to make this a little bit smaller so we have some room. That didn't really work too well. Alright, so let's take this equation and combine it with our one up top. Now our y's are going to cancel. We're going to add them together. So we're going to get 3z equals 6. So z equals 2. Now you can substitute this in to either one of the star equations because these are the ones that have only y and z. So let's go ahead and substitute that in. Let's do the star equation. So we get -y minus z, which we found was 2, equals a -1. Add 2 to both sides. So -y equals, what did I add to? So +1. So y equals a -1. And now that you have z and y, you can substitute it in to either the blue, black, or purple equation. It doesn't matter. So let's go ahead and sub it in to our blue equation. So we have x minus 2, y we said was -1, plus 3, z is 2, equals 9. So you get x plus 2 plus 6 equals 9, so that's 8. So x is going to equal 1. So our answer would be x, comma y, comma z. Alright, so there's that problem. Go ahead and pause it if you need to write anything down. I'm going to move on to example 2. Alright, example 2. Same thing. 3 unknowns, 3 equations. So look for the ones that are going to be the easiest to cancel. So here, I think y is going to be the easiest, or z. It really doesn't matter. I'm going to go with y's. So looking at my y, here's my negative. I want to make sure I have that in both systems. So with that being said, I'm going to take equations 1 and 2, add them together. So I get 3x plus 2z equals 9. Now I'm going to take 2 and 3 and add those together. So I get 5x, my y's cancel, my z's are going to cancel too, and then that equals 5. So amazingly, I have x right away. X is 1. Let's go ahead and sub it in here so we can get z. So 3 times x plus 2z equals 9. 3 plus 2z equals 9. Subtract 3 from both sides. 2z equals 6, so z is 3. Excellent. So now we have two values. You can substitute this into any of the three equations. I don't know, I'm kind of liking number 1, the blue. X plus y plus z equals 6. So 4, subtract 4 from both sides, so y equals 2. So your answer is x, comma y, comma z. 1, 2, 3. Awesome. All right. So like I said, it doesn't matter which equation you choose. You could have decided to get rid of your z's. You could have chosen to start with equation 1 and 3 and then 3 and 2. It doesn't matter. As long as you're using one of the equations twice and that you're using all three of them. Let's look at the next and last example, example 3. So here again, 3 systems, 3 unknowns. I'm going to go ahead and work with equations 1 and 2. So looking at them, there isn't anything that's going to easily cancel out. I'm going to focus on my x's though. So with these two equations, we know combination. If we multiply the first one by -2, we'll be able to cancel our x's out. So this is just being written with multiplying by -2. If I do that, I'm going to get a -2x, a positive 6y, a -2z, and that equals -2. Now I'm going to combine that with equation 2, so I'm just rewriting this. I'm going to add those together. My x's cancel, and I get 5y minus 4z equals 0. All right, now let's take equations 1 and 3. That looks like it's going to be nice because I just need to make one of them negative. So I'll make the first one negative. So it's a -x, a positive 3y, and -z equals a -1. Then I take my third equation, add them together, my x's cancel. You got 5y minus 4z equals 2, -2. Okay, good so far. I might have mixed up my signs a little bit here, but the idea is the same. Let's go ahead and move this. You should get, when you combine these two together, look what happens. When you add them, I definitely messed up a sign somewhere. Did I move? This is right. This cancels. I definitely messed up somewhere. All right, let me pause and see if I can find my mistake. Hold on. Oh, email. All right, never mind. Overthinking. Okay, so I need my y's to cancel, so I have to multiply one of them by a negative. I was thinking of the answer in my head already. So this is the first one. That's this one here. I'm going to multiply this equation by a negative so that my y's will cancel. And I get -5y, a positive 4z, and a positive 2. Here it goes. This cancels, so 0 equals 2. Well, we know it doesn't, so those aren't equal. So there's actually no solution to this problem. No solution. So it's inconsistent. All right. So don't worry if you don't get an answer. It's okay. It just means that all three of your lines are parallel. Let's go ahead and try this. This is what I'm going to be checking to see if you got it right for homework. There is an answer to this one. So try your best, and I'll see you tomorrow.